Good morning, friends. Welcome to the Slight Alumni Association's YouTube live on automation in welding processes and technology upgradation in MIG oblique TIG welding. So this is a very technical session by veterans of the industry who have been working from the last more than 20 plus years in this particular segment, and they are working in a big way. So I would like to introduce Mr. Ashok Pal Singh and Mr. Harpreet Singh, who are both veterans and Slightans into this particular profession. So I'll request Mr. Ashok to introduce himself. Ashok ji, please.
Good morning, friends. Myself, Ashok Pal Singh. I'm actually working with the SMC Corporation India Private Limited. This is a Japanese organization, multinational company, which is the largest manufacturer of pneumatic and automation components. So right now, I'm working as a senior sales manager located in Chandigarh region, looking after the area, say Himachal, entire Himachal, part of Punjab, part of Haryana, and surrounding areas. So today, major session will be of Mr. Harpreet Singh Bhui. He will be giving a presentation on welding procedures and all that. And a small part of my contribution or my sharing will be on the industry 4.0, which will be mostly the terms related to 4.0. I will be explaining in a very simple way. I will be explaining on that. So I will hand over, say now, to session to Mr. Harpreet Singh Bhui. So please, sir.
Thank you, Prisa and Mr. Ashok. Myself, Harpreet Singh, I'm Citian and I've done my BTech into welding technology. For the last 15 years, I'm into robotic and welding automation and upgrading the industry from manual operations to the automation. And so we are working with many brands, companies in Punjab itself and all over India also. We have, till date, we have done more than 80 plus robotic installations throughout in India and particularly into welding applications. So today's my main presentation is what is automation, why is the automation needed, and how the automation can be done, particularly into the welding applications. And thereafter, what are the new technologies that have come in the welding procedures. So let's start with my presentation. Yeah, I am a founder and the technical director of Brahm Robotics Private Limited. This company is mainly into welding and robotic
Harpreet, kindly yes. full screen the presentation.
Sure.
Yeah, please.
So Brahm Robotics, here we do provide turnkey solutions to the customers for the welding and robotic applications, and we do also robotic integration. So first, why there is need of automation in manufacturing industry? So nowadays there is a lot of repetitive jobs we do, and there is a potential of some dangerous tasks which humans are being done. So automation helps the company or organization to achieve higher productivity and efficiency level while increasing the quality and productivity. Automated production systems require less or no human involvement. Such systems also carry out assembly, sorting, testing, welding, and material handling operations. In material handling, some heavy parts are lifted and ergonomic issues are there. So these all can be automated. So in coming to the next level, increase in production output. So as of there is a lot of production requirements are there. So the repeated operations that can be done are automated. This means that you can increase your overall production output by having your machines run for longer periods. Furthermore, use of machines can allow you maximize your production space by adding more workstations. Increase productivity, quality also of the products. Machine can be programmed to perform highly skilled and precise motions. For example, like CNC machines are there nowadays, robots are there, which can increase the consistency and quality of your product. When production processes are operated, you can have the peace of mind that quality of your products will remain at the satisfactory level. This will save your time, money, as fewer scraps will be generated and rework will be less. Uh, as of day, human safety is more involved. So transferring some dangerous tasks to automated machines can make workplace safer. Since the Occupational Safety Health Act signed in 1970 has been employed, so the people working over there will have a safer safety to their lives and better workplace. Systems versatility. System flexibility, easily retooled and repositioned for your production programs. So this is a flexibility in the automation also. Robots are flexible and can easily redeployed for new application. Robots have ability to easily switch between wide range of product without having completely rebuilt production lines. Quick changeovers are possible. Auto gripping, vision systems are can be incorporated with robots, and same parts can be run. So in production, it can be a batch production also. Some mixed products can be also can be used for the robotic automation. So coming to the welding industry, automation in welding is most important as the working area is very hazardous. There's a lot of fumes, a lot of heat is there. So availability of skilled manpower is also getting scared. So the competition, quality, productivity, price has to compete with these parameters and to look forward for the welding process automation. So in automation, there are three types of major possibilities: fixed automation, programmable, integrated automation, and flexible automation. And types of automation in welding. There are some special purpose machines, robotic welding automation systems, robotic welding automation with quick changeover mechanism. So I'll be explaining these two headings: automation industry and the types of automation and their interlinked systems. So special purpose machine, as the name designates, these machines are used to operate a set of operations which are predefined.
So, guys,
In
this is very,
welding,
very important. Please carefully listen to this thing because this is something which is completely technical and required in almost every industry, be it chemical industry, be it mechanical industry, be it automation or any kind of industry. This kind of things are actually required at every level. So, I would request everybody to kindly listen carefully what Harpreet ji is going to tell you. It is his sheer experience. It is not theory. It is his experience which he is going to tell. Yes, sir.
yeah. In welding SPM, only selected variety of components can be welded. Most commonly used for welding are circular or linear components. Uh, as you have seen in automotive, also in agriculture industry or in some fabrication industry, most other components have linear or circular welding. Some shaft or flanges to welded, some beams are to welded. That is all linear welding. So these can be, and if set of uh, components are there, and you have to weld in production, so low cost automation is the experience. So manually you load the part and you run the system. I'll show you some videos for this experience. So, are you getting my voice? Hello?
Yes.
This is a typical agriculture component. Different flanges are there at a certain pitch. So this is a SPM. We are these components to welded from the both sides.
The robots are doing the welding. Great.
No, this is a special purpose machine. This will be doing this very application.
Okay.
So
This
it
in
is
this
already,
particular application, there is a application of pneumatics. Say this head, which is
yes,
moving ahead and back and fro. this is loaded on a cylinder, pneumatic cylinder, which is forward and this head. So
Yeah.
Only the that it has to be why Mr. Harpreet, we are giving them two systems like that, say welding
Yeah. So
for
all
welding
major,
tire system, pneumatic systems.
yeah.
They are supplying.
So a lot of the pneumatic system we are using are from SMCs itself, and this SPM has AC motor and pneumatics also. So everything is being programmed through PLC, and HMI has a human machine interface from where we can select the variety of the component which has been already reprogrammed into the SPM. So once the batch is completed, you can run the next pre-programmed component on the SPMs. So just coming to the SPM, there are examples of fixed type. So this SPM is example for the fixed automation. Like earlier I explained, the type of automation, fixed automation means you are doing a particular job operations. So it is also known as hard automation, where designed to complete a single set of tasks repeatedly. So I think everybody could have understood this SPM format. Now coming to robotic welding automation, robots are used to weld geometrically different components. Some their profile components, some larger components, which while welding the operator feels the heat also, and his skill level also required. So these all can be collaborated with the robotic automation. So different components located and clamped in jigs. So it can perform welding as per the sequence program. And this sequence of program can be reorganized, reprogrammed, edited, and number of times. So it's very flexible to do it. It is a type of programmable integrated automation system. Programmable automation is completely used for settings where similar items are produced during same automated steps and tools. So I'll just show you one of the videos so you'll get better to understand on that. So these are the automotive components, different geometry. This is a jigs, which are, this is HMI. All the signals are coming over here, whether the component has been clamped or not. Has been clamped or not. Doesn't, so if operator has missed to load one of the child part, then also the system gives the errors. So there are two workstations. One is a loading station, and the other is the unloading system. So once at station one, robot will complete his job. Operator is loading next job on the second station. These jigs are designed to level of poke-yoke also to eliminate the failure of the part rejection. So again, this system has
entire clamping, declamping is done by pneumatic cylinders. And these pneumatic cylinders, the stroke of pneumatic cylinder, whether it is forwarded or reverse, this is also being fed to the HMI. That is through the reed switches, which are mounted on the cylinder. So actually, it is in forward stroke or reverse stroke that is there in the system. So immediately operator will come to know that you can read that reed switches. So these are the position of the cylinder, what they are telling.
Yes.
So guys, there is two comments for you guys. Karamjeet Singh Gale Saab says, great to see you, Pui Saab. He's very happy to see you, Pui sir. And secondly, RG and company Mohali says, welding automation can vary depending on the process and the components used, such as columns, rotary tables, or positioners. Need some guidance on this. Can you guys please guide
Yeah. Yes. Turntables can be also incorporated. I'll show you the videos also. The projects we have done with turntables, friction indexing is there. So this was a robotic welding automation, and it is a programmable system. As earlier in I just told you, programmer integrated automation system. So next comes the flexible automation. In flexible automation, integrated automation involves totally automating manufacturing plants with minimal human involvement. Computers can be used. Basically, this is a SCADA-based system. Can be used for design parts, test the completed design, and then fabricate the new parts. So this is a CAM-based programming system. So you program your components on your CAM software, then load those programs to the robot, and jig is all there. Load the component jig, and robot will perform the similar application on the component. So it's a part of robotic automation also. So integrated automation can be used for continuous process manufacturing and batch process manufacturing. I'll show you one other video. So over here, there are different parts. This is one of the jig on components being welded, and there's you can see my cursor. There's another part. So they both are of a different geometry. So once this is done, robot will doing this welding over this jig also. And I just want to brief. This is aluminum component. Mostly in industry, it is welded with TIG application. Over here, we are welding through pulse MIG. This process is faster than the TIG process, and you get the same ripples as you will get in a TIG. Earlier, this component was welded manually through TIG process, and two welders were welding on this component, and they used to take 10 to 15 minutes to weld this component. Now, through robot, we are able to weld within 4 minutes.
So this is the kind of flexibility what we are having.
Yes.
This is what automation is playing there.
It's all about. Yes.
Yes, exactly. So welding, otherwise, the time what Mr. Harpreet has mentioned, that it takes around 12 to 15 minutes. Now it is done in 4 minutes. That is only because of automation. That
Yes.
part is only operator has to place the part, and rest operation will be done automatically.
Yeah.
So and the quality of welding, you can see that it is perfectly consistent. You can that quality will be consistent. There will be no say where
This
somewhere it will be more or less. Exactly.
madness.
This is
And
what
this
we get
blackening is
through
due to
automation.
the blackening during weld is due to oxidation, so it has to be cleaned back chemically later on. Now coming to the welding process, that can be automated. As technical name is gas metal arc weld, we call it as MIG. Gas tungsten arc welding, known as TIG, then resistance welding, laser welding, flux core welding, plasma welding. These all can be automated through SPM mode also and through robotic mode also. I'll just show you one of the video of SPM for the tungsten arc welding. This is a submersible motor housing. So it's both end flanges were welded manually through TIG process. So we have designed this SPM with auto TIG filling system. And there's a circular part as you can see on the video. Only operator has to load and load the part. And this machine is designed to adjust different lengths of these cylindrical submersible pumps.
So the rotation of this cylinder is being done through, you can say, through the drive, servo drive.
And the torch slides are up and down movement is through pneumatics, and that.
Yes.
So similarly, as I've shown you earlier, the MIG welding stream also, tungsten welding also. So now coming to the new technology available in MIG welding applications. As you all know, if the thickness is higher than 15 mm or 20 mm, so we have to either prepare a groove, then make a multiple layer welding. So in that case, there is a lot of distortion also. Now you can see, this is a 20 mm plate. You have to make a large groove. Then there are multi-pass welding. Lot of distortion is there. So now there is a new technology has come up that is known as D-arc, and basically it's a buried arc technology. No groove is required. You have to just give 1 mm gap between both the plates. Single path with full penetration is there. Can you imagine? And the wire size is 1.2 or 1.6. Over here also we were using 1.2 with multiple layer, lot of distortions coming. This is single wire pass and wire size is also 1.2. But the technology is such that it welds through the part and gives distortion, less distortion in the part. I'll show you one of the video. Sorry, the video is missing right now. And gas is used is also CO2. That is very cheaper gas. No argon mix or such gas are required. So the advantage is there. Either you will be using SAW, submerged arc welding, or the comparison is with the DR. Angular distortion there is, and it has single pass value and full penetration. Process flexibility is there. This can be used with robot also. This cannot be used with any type of automation. Either linear welding or circular welding application can be used for saw welding. This can be used with robots also for different profile welding also. Wire consumption is higher. NS wire consumption is low. Heat post process not required. Welding speed is higher. This deposition is again higher over here. I'll show you graphically over here. This is the deposition rate and this is the current that is being used. We will be using from deposition 100 grams per minute to somewhere around 350 deposition with 1.5 mm wire. Whereas with saw welding, 4 mm wire is being used and 6.4 wire is also used. So production rate is much higher in this D-arc system.
Harpreet, there is a question: the cost of robotics welding versus cost of manual welding process. How robotic welding can lower cost of production, and how automation welding process can save some cost besides having great technology?
Yeah.
These are by Mr. Vivek.
In automation, during welding, all the parameters, whether you fix the parameter, SOPs are followed by the industry, but somewhere it is all dependent on the welder. So he, as to his convenience, he readjusts the currents, voltage or welding speed. If he is tired, he'll be using his own method to weld. So there will be quality issues in the component. Whereas in robots, all program parameters have been reprogrammed, cycle time has been already established, so there is no chances of variation in the process itself. Moreover, on consumable cost, when welding parameter has been fixed, optimized, wastage of wire and gas is not there as compared to manual applications. So, in our experience, we have come across manual operation versus automation process, there is a saving of 15 to 20% on consumable itself. Consumable means MIG wire, torch consumables, MIG, contact tape, and others consumable parts, and in fact on the gas also.
And time is also reduced in a way to work
Yes.
on, right?
Yeah.
And the quality of work is also improved.
The part produced in the morning and the part produced in the late in the evening will have the same quality.
Yes.
And
So
moreover, yes.
Sorry, please carry on.
Yes. Please.
There's one more question has come up. The great sharing, Harpreet ji. A lot of new materials other than metals are being introduced these days. Do your company deal in non-metals or non-welded automations also?
No, we are currently presently purely into metallurgical applications only.
Okay. Fine. Ji sir, please carry on.
In automation, how the people go for the automation vis-a-vis to the manual operations? They call us and ask us, sir, this is the component we are producing and our current requirement is such numbers per day. And we have 10 welders right now to doing this operation. So you give us the proposal. So we work on the concepts, how it will be welded, how many stages will be there, can it be welded in a single stage or multiple stage, and what will a total welding cycle time for the part. So we give them a comparative cycle time also. I'll just share you one of the cycle time. Here is a part, I'll just show you. It has 13,800 mm welding. Means 13.8 meter welding. Is it visible to all?
Yes.
And it has 106 points from where one welding and other welding has to start and restart. So we have calculated cycle time. So it comes 43 minutes at 80% efficiency. 80% efficiency is because this system at the end of the day is to be run by human beings. So we can't go by 100% efficiency. So it's an industry standard. We use at 80%. So in 1 hour, one component in shift, and we have taken a shift as an 8-hour shift. 9 components will be produced. So from here, the company can analyze whether this system will be beneficial to them or not. And this will be having only one operator. Whereas for this welding for this component, they are using 5 to 7 welders. One will be pre-tacking, then moving to next stage. He will doing the next level of welding, then moving to another station. So in single station, this will be all done through robot.
Basically, the removal of part from one welder to second welder, it is clamping, declamping, then transferring that part to other welding station. So that is a lot of time goes in that. And
a lot of time, energy is also required because this is a very heavy part, but they need a crane movement also. So once they will load into robotic system, they will completely weld and get out of the system.
Yes, exactly.
So now coming to next. As you all know that in MIG welding, manually when you are welding, there is a variation in hand movement. Basically, arc length changes. If all the welding people will be knowing that. So the arc length change impacts on the weld bead quality as well on the penetration at the joint. So to maintain the arc length and the spatter level, as the arc length increases, spatter level also increases during MIG welding. So in most of machine there nowadays they're coming with microprocessor, arc control systems. So nowadays earlier it was on microprocessor base. The arc correction was into 1 seconds. Now it has come to 20 nanoseconds. Means it's a 5,000 times faster arc correction. Means when manually you are welding the component, if your arc length changes in nanoseconds, the machine corrects the arc length also. How it corrects? It takes the feedback from the arc voltage and gives to the wire feeder. It increases the arc length. So that arc length is so precise that it maintains the arc length as per the component we have predefined. Moreover, it helps in the achieving welding in faster mode. I'll just show you. High speed welding mode. So there is short circuit, then the arc stability. So this is the arc will be maintained with the correct current waveform in real time. So the weld bead will be uniform like this. This is through the nanoprocessor, यानी कि high speed mechanism and latest technology. This is the conventional machines. And whereas spatter level is also less, that is micro spatters. Any question on this?
Yeah, guys, any questions, please come up so that they can answer your questions if you have any. All the students in welding technology can ask the questions from slide, then Harpreet ji can answer them immediately because you guys are studying it and it is something really industrial which is required. Vivek Singh is writing a great knowledgeable session. A big thanks to all. Thank you, Vivek ji, for joining. Yes, sir. Yeah, carry on, sir.
Okay. So this is the latest technology that come up, that is the high-speed welding. Most of you have seen the people who experience MIG welding. The MIG wire, when you check your MIG wire after welding, there is a droplet formation at the end of the wire, like this. So how this droplet helps in reducing the starting arc spatter level. You must have experienced when the arc is started, then a lot of spatters are generated during the first short circuiting of the wire with the base metal. So when the surface area of MIG wire will be increased, so it will be creating more short circuit area will be happening over there. So it will create spatter level. So now technology has come up in which the wire, the globular formation is very less. That will reduce short circuiting area also and the generation of spatter also during the arc start itself. So this is a pictorial, so you can very well see over here. Over here, there are low formation is there. There is a thin formation. So these are the technologies that have come up for the thick applications also, and for the thin application. We have a system that can weld. You can weld 1 mm sheet thickness with 1.2 MIG wire. This is known as this technology known as synchro feed, and without change in the wire, you can weld thick plate also with 1.2 wire. Like this, you can see plate thickness 1.6 mag, and you see the current and voltage also. And this is the penetration, and bead is very flat.
So, sir, there is one more question from Gurusevak Singh Uppalji. He says, "What's Brahm's USP in being top robo supplier? While there are so many available brands available in the market, cheaper like Kuka, ABB, Yes, Kawa."
Yeah. Actually, USP, as we are robot integrator and we are associated with one of the world's renowned company, that is OTC Dahan. It's a Japanese company. So their USP is there. They are the single source manufacturer robots as well as for the welding machines. And they are different variety of welding machines for different applications with different technologies. And we, being their robot integrators and distributors, the customer has the advantage of single source service provider. So as you know, robots are standard equipment. They has to be customized, automated as per the application. So in industry, there are different applications that varies from component to component, customer to customer. So we give the turnkey solutions to the customer. That includes robot
Actually,
plus welding machine.
yeah, it is like that. That company, the company mentioned by Gurusevak Singh Uppal, they are only into the robots, not into the robots or cobots. They are not into the welding equipments. So the USP of this company is that they are having both the things, all the things related to welding. So they know the in and
Yeah.
out of that welding field. So that is why that is more preferable over the others.
Yeah. So in robotic system, what happens once the solution has been installed and handed over to customer, it's a very simple that some problem is going to come in future also, some breakdown robot or welding machine or in an automation, whether it is from operator side or from system. So customers is all dependent on this automation level for their production. So once there is a breakdown, so immediate first they need the immediate service call back from their solution provider. So being a single source, we know if we confirm that they have such and such problem, so we can easily diagnose whether it is on robot side, it's on welding side, or it is on the automation. So accordingly, we can give him prompt service call and service base also. So that gives us the advantages of being a single system supplier.
Great, sir. Brahm Auto Robotics is one of the very, great companies doing such kind of activities. So there is few questions and few comments for you, Pui
Yeah.
Saab. So one is
Okay.
Vikram Nanda says, wonderful topic of robotic and automation in welding. I only read robotic welding in books as a part of academic curriculum, but seeing automation in welding on all these videos is really great feeling. So he's feeling great, and he's saying ki, wonderful. Thanks for sharing your experience with these videos, which give more clarity on time saving and quality of welding. And he's again writing, current GWT graduates of Slide will learn watching all these automation and may help them to grasp the automation with ease. Thank you, Ashok Saab and Harpreet ji, for this wonderful presentation. And there
Yeah.
is one
Thank
more
you.
question for you. Yes, sir.
Yeah.
Vikram Nandaji is enjoying welding on YouTube. On videos by you guys, and I'll tell you all of you that these videos are the real works of Brahm Robotics, and being founder of Brahm Robotics, Harpreet ji have been involved in all these works himself, so he knows the things ins and out. So you guys can learn from him a lot and can really build your career in this particular segment. So Raj Tagore says, sir, welding tool cleaning and changing is also required from time to time. Is this manual or automatic? How is this done?
Yeah. It's a depend on the whether you invest on the torch cleaning station. Torch cleaning stations are there, so we also provide those torch cleaning station. We program as per the component length of welder and the possibility how many spatters are generated in the torch itself. So it's a cyclic process. Robot after welding 10 or 15 component automatically goes to the cleaning station and torch cleaning operations done and back to his work. I'll show you one of the video. You can see through my cursor, this is a torch cleaning station. And in this torch cleaning station, there are 5 operations carried out. That is trimming of wire, then nozzle outer cleaning, nozzle internal cleaning, then gel dip, then extraction of extra gel through the nozzle. And that extra gel is again transferred to the gel bowl. So it's all run on pneumatics with only 120 volt control system. I think the operation of this video, this task is not there in this right video.
Yeah, but good. I think this is something very amazing which is happening in the industry, and
So
we are very happy to see
just,
you being a part of it.
So you can see over here, wire trimming is done. Over here, internal torch cleaning does, then outer cleaning, then there's a bowl right over here. Gel is there. You can dip nozzle. This is all auto programmed. So after suppose these component, there are 10 cycles, it will go automatically to the station and all these operations will happen. Okay, let's move into next. Yeah.
Operator is standing by side and enjoying.
Enjoying. Actually, I was preparing that. So now coming to robots in handling automation. This is CNC turning centers. This robot is cleaning chips also, then unloading the part, loading the new part into the chuck, and then it drops into the bin. This is the input tray from where it taking up the components. So this tray is multiple tray, and it is this tray designed for the capacity for the 3 to 4 hours production.
So this is basically what the robot end of robot. There is a gripper, pneumatic gripper, which is holding the component. So it is feeding to the 3 to 4 machine depending on the operation on the part. So like that, it is feeding and removing that part from the one machine, then feeding to the next for the next operation like that. So this is, I think this eliminates around 4 to 5 people which are involved in this process. So this is how automation helps the industry to reduce the manpower and you can say create, generate more production and all that.
So I just want to elaborate one more thing. This CNC turning machine didn't have automatic door closing and opening system. So we all incorporated this into that machine.
Yes.
So now this system doesn't need any lunch break or tea break. So it will keep on performing into that time also.
Yes. Yes, exactly.
Yeah. Now coming to next. This is press standing. There are 2 machines. One is the assembly press. This is a steel rims being assembled on this press. The robot takes out the component and it loads into this welding SPU. And this robot unloads the component from there to the conveyor.
This is a this is a steel wheel, or you can say rim of a vehicle, which is being manufactured. So entire thing is automation is there from the pressing to the welding application.
So all safeties has been taken care during programming and automation of the system. If robot is having no component, we have next level operation safety mechanism that machine will not run or robot will not interfere with each other also. So this project also has been done by our team. So thereafter now coming to welding industry of 4.0. So as industry 4.0 is gaining a lot of importance into the today's manufacturing. Basically, it is based on Internet of Things, IoT. Industry 4.0 in welding, the real-time welding data you get on your desktops. It's basically automated weld monitoring system. It brings digital connectivity to the welding department. So what happens, whether it's a manual operation or the automation solution, we have a technology that can be connected to your desktop and you can real-time welding details like you have set up a machine at 100 amperes and at 14 volts and the length of weld also been defined. So you can get the data on your laptop whether the production done on that machine, particular station, what were the welding time, what was the current, what was the voltage, and in fact, what was the input voltage also. The input means main supply. That whether it was 220 volts, 420 volts, whether it was 415 volts, or any inline fluctuation was there. And moreover, the wire feed rate also you get. Feed rate is more important in welding because feed rate is bending directly proportional to the current also. As you increase or decrease the current, wire feed changes. So in case your arc length changes, wire feed again changes. So if the motor heats up or the wire feeder, it will be less efficient and will not be giving proper feed rate. So that data also you get on your system. I'll just show you the presentation, one of the presentation. Simple data log function. You get the current, voltage, wire feed speed, errors. What are the errors has come up? This is IoT based. Monitor whether a welding machine has stopped. Earlier detection of abnormalities like machine is getting heat up, wire feeder is getting heat up. Any input voltage has increased out of the range. So through PC Internet Hub, you can connect 100 welding machines and get this all data on your desktop also. What are the user information care processes, what processes we define, who's the welder. So even on the automotive industry, there are barcodes. You can have barcode reader also, just to trace the component, whether during some field failure comes in automotive industry, you can trace whether it was a welding error or it was a material default. So these all system you get online on your real time on your desktops. You get also the complete data of what was the component, date, who was the welder of the day, and it's very intuitive interface for the supervisor or the welding engineer to manage their welding details. Any question on this part?
So I will be explaining few terms majorly or mainly connected to the 4.0. I will be explaining very in a simple language so that that could be understood by the attendants. So like Mr. Harpreet Singh has told about the 4.0.
So this system can be also collaborated with robotic system. Record what is welded, where, when, and how. That is more important. You get real-time notifications and information on your desktop. What was the gas supply rate, gas pressure, welding power supply, primary voltage, internal temperature, powers, even cooling fan. Because as the machine temperature heats up, due to inefficient fan cooling, the output also varies. So you get feedback of welding cooling fan also. So
So actually, that affects the weld quality of weld.
welding
Actually,
quality, yes, welding quality.
yes. So that has to be controlled, or that feed also required in that case.
Yeah. So the feedback is in 100 milliseconds or 50 milliseconds at a sampling frequency of each weld gun. And with the one software, you can connect 32 robotic system.
Superb, Harpreet ji. This is something really fantastic which is happening in the industry. Now, I would like to. There is one more question from Gaurav Chitwal. I
Yeah.
would like to present this. It is for Mr. Ashok. What is the future of Industry 4.0 in India? I think now it's Mr. Ashok's time to take over the things, and he can talk about 4.0. Can we, if you want to present something, then certainly you can present. Harpreet ji, we can come out of your presentation
Sure.
and he can start. Yeah.
Sure.
Mr. Puri, can you share my screen?
Just hold on. Please, present yourself first, Ashok ji. Please add on.
I think
I think your screen is very visible now. Please come over the presentation.
So this is one slide. I think it is visible to all.
Yes, yes.
So these are the few
You
big
can do the full
latest
screen,
terms.
sir. Please do the full
Yeah,
screen.
sure. This is
Yes.
few terms which are related to, you can say, 4.0. This is autonomous robots which work for the entire system. It's a big data, augmented reality, AR, what we say, additive manufacturing, cloud computing, cyber security, internet IoT, which Mr. Harpreet has also said. System integration is there. So simulation is there. So I will share a small video of 2.5 second. Just a minute. So it will just give an idea. So how SMC is working on Industry 4.0. You can just have a look on that.
Can you please full screen it?
This is what. So this is a small video, just giving you can say the way how Industry 4 is now integrated into the industry. So what is the requirement of Industrial 4.0? It is actually the most live example of Industry 4.0 is nowadays is the, you can say, Amazon. So earlier to this, this is the fourth revolution, industrial revolution. In the second, say third industrial revolution, what is the industry is going for the mass production of everything, and that is the requirement of at that time. Now the this thing has reduced drastically to the, say, lot size of one. Say now what we are ordering on Amazon, that every person, every single, we take an example of a shoe. So every person is ordering, say at one time, say 100 people are ordering shoe on Amazon, and they are ordering as per their requirement. Say of single company shoe, they are ordering 100 people are ordering 100 pairs of shoes on Amazon, but all together different. So now the Amazon has to provide them the shoes as per the requirement of the customer need. So that is why the now the lot size of item is one. So that is why Industry 4.0 is required nowadays. Now that machine has to be, say earlier setup what we are having earlier to this, that is a big huge lot, big machinery producing the things in uh, millions of numbers. Now that is not required. It has to, machine has to be designed and optimized to that level that it can produce a one pair, and second lot will be of another pair, like that, with the customization of the shoe. So that is why, so machines are now designed in that a way that they can produce 100 type of shoes in one machine only. Earlier it was not there. So that is why the requirement of Industry 4.0 is nowadays picking up. And the question of Mr. Gaurav is there, that what is the future? Future is really actually Industry 4.0 recently started. So it has just you can say in India it is just started. Only the big groups like HUL, ITC, Dabur, and these big MNCs have just started the 4.0 in the industry. Otherwise on the industry on the lower level, yet not that, since it is a you can say the automation of that level, small industries are not able to afford these technologies actually. So what these terms, what big data is that? So big data is basically what we see, that it is a real-time data flow, exchange of data, complex and you can say big datas, number of datas being transferred and shared. That is basically a big data. Augmented reality is what, say likewise you have seen that in a video, that particular you can say component which failed. So now the person sitting at other place, say distance, sitting on other side, but there is a problem in site number one, he is sitting at site number two, but they are sitting there, he can actually see the component details there sitting on the laptop itself. That is basically what this component includes, how it functions and all that. He need not to refer the books and all that, which may be or may not be available with him. So that is augmented reality, AR, what we say. And then additive manufacturing, so we can add and delete the material or depending upon the process. That is basically augmented reality, what we are talking about. And cloud computing, so calculating all these datas at very high speed, and high speed you can say. So that is basically requirement of this thing. And internet of things, so now the components which are being installed in the machine, those are with the sensors. So real time data, they are transferring that data to the you can say the required peoples. So that is real Internet of Things, say, which is required to for the real time monitoring. Just a minute. So, big data is preferably data sets that are too large or complex to be dealt with the traditional data processing application software. So, this is what Internet of Things, IoT, physical object with a sensor processing ability, software and technology that connects and exchange data with the other devices and system over the internet, that is other communication networks. That is what IoT is there. So simulation before running simulation stands with the before running a actual process, we can do it on a simulation and check for the abnormalities of the process. That is what we simulation is required. So these all terms are basically basic terms of industry 4.0, which are you can say collaborated, and which consist comprises of 4.0. So and why we say that industry 4.0 is a separate, but why this pneumatic is used in you can say uh, these automations. So these are the few you can say advantage of pneumatic. This is a compressibility of air, why it can be compressed to achieve the desired pressure. So that is the compressibility of air. Simple in construction, easy to handle, nothing is required, special equipments are not required, only compressors are required. So that is and air is available in abundance in atmosphere. That is why this is a use ability to control and pressure and force. There is every control of pressure and controlling the system is in our hand. Then fourth point is low maintenance. Why it doesn't require much of the maintenance like hydraulic system, and it is bit cumbersome to maintain the hydraulic system. Then explosion proof. There is nothing kind of explosion there. It will not a inflammable thing. That is another thing. Low cost. Costing over entire pneumatic system is very low as compared to the other. You can say electrical, even electrical actuators are there, and hydraulic systems. It's not. It is a simple, not very complex, as well as costing is very less. And you can say sixth one is fireproof. This is what basically pneumatic system is adapted in the automation industry. These are the few things which makes this system, pneumatic system, as a you can say heart of automation. So this is all from my side. Any question from
So others says really a great session, and he says being a slightly and proud of what alumni is sharing lifetime experience and sharing practical knowledge. Keep on doing this kind of work. It will make us equipped with technology upgradation going on. Yes, certainly others. That is why this YouTube live series has been started in order to tell share our knowledge with each other, and that's what exactly is the reason why we are here, and we are working hard in order to give information. And Gursevak Uppalji is really happy. He says, great session. Kudos to Harpreet Singh and Mr. Ashok, and even he's appreciating me, Sarabjit Singh Puri, for bringing such a knowledgeable session. So thank you, Gursevak ji, for actually joining here, because these YouTube series are successful only if you guys join. I will request every slide student, every slide teacher, and every slide alumni to please join the sessions and do watch them at least 4 or 5 times later on also, because there are a lot of information and knowledge which is being put in, and a lot of hard work is being put in by all of us. And the kind of information or knowledge which is being shared by these guys who are coming up, like Harpreet ji and Shok ji, is that they have put in whole of their lives into this particular segment, and that is why they are able to give very detailed information about it. And I would like to suggest, please be in touch with each other, go to each other factories, go to each other's offices, and connect with each other. Not only same batch, rather every batch should go and meet each other and understand what exactly the people are doing. Refer each other to the other clients so that you can get more business out of it. Help each other in getting more jobs. So this is what exactly this alumni association has been made for. So please come up and watch the videos and help each other. The concept and the vision of this association is to connect, support, and grow. So guys, please connect, support each other, and grow each other. This is how the slide will become one of the most prestigious institutions in the country or maybe in the world in the coming days. This is what we want like to see. Thank you, Harpreet ji, for such a fantastic session and really, really eye-opening and very new things which we have seen come happening in the industry. And thank you, Ashok ji, for really joining and
Thank you.
giving your precious
Thank you,
time.
sir. Thank you,
Thank you
Guruji.
very much.
Thank you. Thank you, everyone.
And thank you,
Thanks, sir.
viewers, for coming here. Thank you.
Okay, ji.